Today we're going to talk about exponents. So we have 4 to the third power. 4 is what we call the base. And 3 is the exponent, which is the power. And we will say 4 is raised to the third power, which does not mean 4 times 3. It means 4 times 4 times 4. My base number raised to the third power. The first thing we're going to talk about is exponential form. Exponential form. This is written with an exponent. So our examples: 4 to the third power, 6 to the ninth power, 12 to the 10th power. It's written with an exponent, so therefore it's exponential form. The next one is going to be expanded form. Expanded form is to write the base number as many times as the exponent states. So when we have 4 to the third power, that means my base of 4 is multiplied 3 times. 9 to the second power, 9 times 9. This is expanded form. You should be able to go from exponential form to expanded form very easily. The last one is standard form. And that would be to evaluate what the answer would be. So if I have 4 to the third power, we know that's 4 times 4 times 4, which is equal to 64. 64 is standard form. 9 to the second power, that's 9 times 9, which is 81. That is standard form. Negative 2 to the fourth power is negative 2 times negative 2 times negative 2 times negative 2, which is going to be equal to 16. I can have 2/3 raised to the second power. 2/3 times 2/3, which is equal to 4/9. You should be able to go back and forth between these 3 forms. So if I gave you an example of 6 times 6 times 6 times 6, that's exponential form. I want you to write that that's expanded form. I want you to write that in exponential form. That would be a base of 6. How many times? 1, 2, 3, 4. 6 to the fourth power. If I ask you to write that in standard form, then that means you are evaluating that. So 6 times 6 times 6 times 6. And that would give you 1,296. 6 times 6 is 36. 6 times 6 is 36. When I multiply those together, I would get 1,296. Okay, the next part, I want you to write down this table. Now, you're going to have to pause the computer, pause the video, and write this down, and then come back to me when you have it all done so we can continue with the notes. So 2 to the 4th power, we're going to talk about how zero and negative exponents work. So 2 to the 4th power, that is equal to 16. 2 to the 3rd power is equal to 8. 2 to the 2nd power is equal to 4. 2 to the 1st power is equal to 2. So what's happening each time we come down our table? We are dividing by 2. So when I always ask what does 2 to the 0 power equals, a lot of people say 0. But that would not be correct, because if I come down here and I'm going to divide by 2 again, what's 2 divided by 2? And that would be 1. So any base raised to the 0 power is going to equal 1. So how would that work with negative exponents? Well, if I take 1 and I divide it by 2, I'm going to get 1 over 2. If I take 1 over 2 and I divide that by 2, I'm going to get 1 over 4. And if I do that and divide it by 2, I am going to get 1 over 8. So how does this work with negative exponents? Any base raised to a negative exponent has to be flipped to its reciprocal to make that exponent positive. So if it's 2 to the negative 1, that's going to be 1 over 2 to the 1st power. That now becomes a positive exponent. 2 to the negative 2 would be 1 over 2 to the 2nd power. That now becomes positive. 1 to the 8th, 2 to the negative 3 would be 1 over 2 to the 3rd power. So in order to eliminate a negative exponent, you need to flip the number to its reciprocal and make that exponent positive. So the same is going to happen with my 3's. 3 to the 4th power is 81. 3 to the 3rd power, 27. 3 squared, 9. 3 to the 1st power, 3. As you can see, what is happening as we go down our table, we are dividing by 3. If we continue to divide by 3, then that means 3 divided by 3 is going to equal 1. 3 to the negative power, not negative 1, is going to be 1 over 3 to the 1st power, which is equal to 1/3. 3 to the negative 2 would be 1 over 3 squared, which is 1 over 9. And 3 to the negative 3 would be 1 over 3 to the positive 3, which is 1 over 27. And again, we are dividing by 3 all the way down the table. Okay, so any number raised to the 0 power equals 1. So any number n to the 0 power is equal to 1. Now for our negative exponents, bring over the reciprocal of the base to the positive which is really the opposite exponent. All right, so if we have n to the negative 4 power, that becomes 1 over n to the 4th power. If I have 2 over 3 and the whole thing is raised to the negative 2, then in order for that to become positive 2, we would need to flip this to its reciprocal, which would be 3 over 2. And that is going to equal 9 over 4. If I have p to the negative 8 power, that's going to be 1 over p to the positive 8. And it works the opposite way too. If I have 1 over x to the negative 5, I cannot have that negative exponent, so I need to flip this, so this becomes x to the 5th, making it positive over 1. And that's just equal to x to the 5th.